So our speaker today, Jeanette, for those who have joined us now late, is a very famous internet person who has founded an amazing foundation who does a lot of Spanish mathematics outreach, FUNDAPROMAT in Panama, who has organized more than 50 live conferences and more than 100 in the last 3-4 months, and has done an amazing work altogether. And I could not do enough honors to Jeanette with this introduction, so I think it's best to see her work and hear her talk about toothpick problems.
So who am I? My name is Jeanette Shakalli. I am a Panamanian mathematician. I was born in Panama City, Panama. I got my Bachelor of Science in Mathematics and Chemistry from the University of Notre Dame and my PhD in Mathematics from Texas A&M University. And I am currently the Executive Director of the Panamanian Foundation for the Promotion of Mathematics, FUNDAPROMAT, like Thiago just mentioned. And what we do at FUNDAPROMAT is that we promote the study of mathematics in a fun and exciting way, like you're about to see. And we organize virtual events that are free and are open to the general public, which means that kids and adults of all ages are welcome to attend. Most of our events are in Spanish. And you can find out more information. I have written my email address as well as my social media accounts, just in case you want more information about this. Now, let's get started with the fun part. Let's go straight to the toothpick puzzles. So as Thiago mentioned, you are welcome to annotate and write on the chat and let me know what ideas you have about the following toothpick puzzles. Now, I just wanted to mention, if you've seen these puzzles before, please do not give away the answers right away. Let's give a couple of minutes for those who haven't seen the answers and haven't seen these puzzles before. Now, this one is just a warm-up puzzle. So here you're asked to remove one toothpick and only one toothpick to leave only 3 squares. So as I said, this is the first puzzle, so we're warming up. And so here we can see that we have 4 squares and we want to remove 1 toothpick to leave only 3 squares. Any ideas? Thiago, do we have anything in the chat?
So far we have someone who says, remove the red toothpick on the left.
Nice. Okay, so who's that someone?
That someone is Varun Gadi.
Okay, do you want to turn on your microphone and explain what your thought process was?
Okay, so I was just thinking that like which squares we should move, and since like the middle square was shared with a lot of the other squares, I decided to test all the 4 toothpicks there first, and then the red one worked.
Beautiful. So you're saying to eliminate, let's see if I can annotate. So Varun wants to eliminate this one right here, right, Varun? And I'm sorry if I'm saying your name wrong. Is it Varun?
Yeah.
Okay, wonderful. Where are you from, Varun?
My name is Varun and I'm from Georgia.
Do y'all agree with Varun? Is that the only solution? Are there other solutions? What are we thinking?
So far, no answers. Sergio says done. And CoM, yep.
Wonderful. Okay, so are we ready to move on to the next one? I don't want to go too fast because I know some people here are math enthusiasts and they've probably seen these before, but I'm not sure if everybody else has. So let's give just one more minute just in case. And thank Varun for participating.
Okay.
Okay, so that was the warm-up puzzle, and I think we did pretty good for the first puzzle. So let's clear all the drawings so that we don't have any marks on the slide before we move on to the next one. So let's see, what do we have next? Ooh, do we have something in the chat, Thiago?
Does every toothpick remaining have to be a part of a square? Asks Gleniba.
That's a very good question. Can you give that person allowance to speak?
So I was just thinking, if you try different removing different single toothpicks, some of them will leave things sticking out that aren't part of squares. And so if you count the actual squares, you still might have 3 squares that you have some excess, some extra toothpicks that aren't part of squares. So I was just wondering what the rules were.
That's a very good question, Glenn. And that's the reason that I like these puzzles. Because usually when you show puzzles, you can get people to think farther, like outside of the box and not just a straight answer, but you can analyze other options as well. So let's look at what Glenn just said. So let's pretend that we remove this toothpick down here, the red toothpick at the bottom. So like Glenn just mentioned, if we remove that toothpick, we'll be left with these two just hanging out. The green one on the left and the blue one here on the right. So do we accept that? Do we not accept that? Because the problem just tells us remove 1 toothpick to leave only 3 squares. Technically, we only have 3 squares left. The top one, the middle one, and the one to the right. Now we do have 2 toothpicks like hanging out there, but do we count them? What do you think, Glenn? Do you think we should count them or not?
It's not very elegant to have those things sticking out, and it makes the solution non-unique. So I think it makes sense to rule them out. I just wanted to make sure.
So I actually agree with you, Glenn. I think that it's not an elegant solution, but it all depends on what rules we set. Like you said, what are the rules of this activity? But it's something good to discuss it with your students, with your kids, with whoever you're presenting these toothpick puzzles to, because you're going to get different ideas, different thoughts from everybody who's participating. So it's good to analyze every single one of them. But in this case, I personally would agree with you. I prefer Varun's solution because it's neat. Like you said, you literally just have the 3 squares and you're done. Whereas in this case, you have 3 squares, yes, but then you have those 2 toothpicks that are kind of like, in the way or something. So what do others think? Do you agree with Glenn? Do you agree with what we've said? Do you think it's better if we include these as possible solutions?
So there has been a small conversation going on off on a tangent. Alexandra added prior to that, know if you are a mathematician. Mathematicians love beauty. And Sergio agrees, and so perhaps it would be interesting to have them talk as well, or
yes, of course.
I was just saying that I agree that we should not accept this solution, the second solution, because otherwise there are a lot of solutions and they are all very inelegant. But I think that if we want to forbid this solution, we should write the instructions a bit more clearly. Like not leave only 3 squares, but leave only 3 squares and nothing else, or something like that. Something a bit more
explicit. I would say. Yes.
Yeah.
Yes, I agree with you, Vivian. But if you want to start a conversation among your students and kids, you can leave it as it is and then reach that conclusion with them. That's another way of getting them too.
Indeed, it's really nice to start a conversation, indeed, about the unicity, about the elegance, and all this. Yeah.
Yes, and I also want to mention something that when I'm running these mathematical outreach events in Panama, it's really interesting how kids and adults are very creative, but they're not used to looking at different solutions, different possibilities. So they're used to seeing something like, okay, here's the answer, right or wrong, done. There's no like deep discussion. What do you think? What do you think we should do? How should we change the problem? Can we change the activity? And so I find that this conversation is actually very enriching and very important. So it's not just saying, okay, here's the solution, here's the right solution, and we're done. But let's talk about it. Why is it the right solution? Are there other solutions? What are we thinking? So I think somebody else wanted to speak as well, Tiago.
Okay, Alexandra speaking.
Hi, Alexandra.
I have to agree with you regarding the discussion of the problem, but I would say that the children probably, like a mathematician, would do the same. I mean, they would probably first spot the, let's say, correct solution. And after you would, I don't know, initiate some kind of discussion, probably they would notice that there are some other possibilities. But this is, I think, a good opportunity to actually talk with them regarding the precise wording of the problem. And precise wording is something that mathematicians actually have to have in order to be proper mathematicians. So I think it's nice to compare to the ordinary language, which is very often imprecise, but that does not mean that people cannot communicate, because usually people know the context of their talk. So it's nice opportunity to talk about the difference between the mathematician's language and the usual language.
Mm-hmm. Excellent. Thank you, Alexandra. I totally agree with you. And another thing is that you also get them involved. You get the participants involved. You get them to relate to the problem, to relate to the activity, and you get them involved in the activity. And that's always a good thing. So yeah, I totally agree with you. Thank you.
So queued up next is Sergi, who raised his hand and should be unmuted.
Sergio.
Yes. Okay, hello. Very happy to have you here, of course. And well, I was saying that here the point is the word only, because if you have to leave only 3 squares, for me it means that you cannot leave any other toothpick. So for me, there's no ambiguity here. You have only one solution here for me. I mean, the key word is only here. If you don't put the word only, then you can open up a very nice discussion. But in this case, for me, it's very precise. So that was my point.
Thank you, Sergio. That's very interesting. So you think that because it already says only, then we would not need to add the and nothing else that Vivian was suggesting. Because remember, Vivian suggested remove 1 toothpick to leave only 3 squares and nothing else. But Sergio's telling us, well, but we probably do not need to say that because it says only already. And so that's a very interesting point. Okay, so here's the next one. So don't you like my colorful toothpicks? I'm very proud of my colorful toothpicks. So anyway, so here's a beautiful design. And now they are asking us to remove 6 toothpicks to leave only 4 triangles. So again, here we're asked to remove 6 toothpicks to leave only 4 triangles.
So far, we don't have any answers. People are puzzling.
Yes, I think people are thinking. That's okay. This is a normal reaction to this puzzle.
Alexandra has already seen 2 solutions.
Alexandra, that's awesome.
Vivian also found one, but she's not sure if this is the only one.
So I want one solution, and then we can talk about whether or not there are more, even though technically Alexandra already said that she found 2 solutions. So she kind of already
we are starting to have the first spoilers in the first solution. So Julia Robinson Math Festival says the top 3 and the bottom 3.
Me, Nancy Blackman. So the top 3 toothpicks and the bottom 3 toothpicks.
Okay.
If you eliminate those, then we...
Let me mark them. Oh, that's a horrible line. Sorry. And that's a horrible line too. But anyway, but you get the idea. So these 3 and those 3, right?
Mm-hmm.
Okay. That's beautiful. Can everybody see that? Or do you want me to try to like mark them on top? I think you can see it by just marking them like that. So yeah, that definitely leaves 4 triangles. Thank you, Nancy. So I think Alexandra said that she had found 2 solutions. So Alexandra, was one of the 2 solutions this one? Or did you find 2 different solutions to the one that Nancy just said?
Another solution, if triangles can overlap, this is by E. Joshi. I think it can be done with 4 toothpicks. So there's already an improvement method of how many toothpicks you should be able to remove.
Who said
Bob,
that?
so that was Joshi.
Okay, so you are one step ahead. One step ahead. Okay, keep going, Tiago.
And Glenn Eva says remove 4 internal diagonal toothpicks.
Wait.
Got one solution without symmetry, so there's definitely some extra here.
4 diagonal, so these 4. Ooh, what happened to my mouse? Here we go. So is it these? Can you give that person allowance to speak to see if it's these 4 diagonals and which one else? Because there are 6 toothpicks.
If you just remove those 4 and you allow overlapping triangles, you have 4 triangles there. The 4 in the cross in the center.
So you said only these 4?
Yes.
Okay, but so not yet. Let's look at 6 toothpicks right now. Let's look at removing 6 toothpicks to leave only 4 triangles, and then we can look at the 4 toothpicks one. Thank you, Yoshi. So Tiago, what are other people saying?
So some people are now asking if we should be removing 6 or 4, but we're still removing 6, and we might move up to 4 in just a moment.
Exactly.
And we can also remove 6 and get only 2 triangles. And so this is we're already starting to have a discussion on ramifications of this problem. I think Alexandra still has not given us the second one.
Okay.
Second solution.
Should we give Alexandra the permission to speak to see?
I'm very curious to see the second solution.
Yes, me too. Me too. And
Alexandra.
you said that somebody had found one that's not symmetric as well. Is that with 6 toothpicks or 4 toothpicks?
I think that was Sergio, and I think it was with 6 toothpick. Alexandra, you are able to speak if you have the symmetrical solution.
So the second solution is also symmetric, and I think in the chat, Bob Hearn has actually revealed it.
So what's your solution, Alexandra? Can you tell me so that I can mark it?
To remove right and left triangle. It's actually the same idea like the upper and the lower one.
Oh, I see. Okay. So you're removing, oh, I'll still draw it. So you're removing these 3 and those 3.
Yes, so this one is also symmetrical, but for me, it's almost the same like the previous one, actually.
Exactly. I totally agree with you. Yes. Okay.
Small rotation.
So, but technically, it counts like a different solution. So yeah, we do have 2 solutions. So Tiago, what else do we have?
So I unmuted Sergio. Sergio should be able to talk, and if he has a different solution, the non-symmetrical one.
No, I was saying the same. You can leave 6 toothpicks and leave 2 big triangles. If you remove the 4 center, and then the purple one and the blue one.
I see what you mean. So do you mean these 3?
Yes, and the other 3 on the other part. Yes. Okay. So you got 2 big triangles there.
Oh, but we are asked to leave only 4 triangles, not 2 big triangles.
Yes, it's a different solution, definitely.
But that's a good one. So we can change the problem to remove 6 toothpicks to leave only 2 triangles. That would be the solution to that problem. Thank you, Sergio. Okay, so what else, Tiago?
So other than that, a user called G says that he has a non-symmetric solution, but would like just to annotate and stay muted.
Great. Can you annotate, G? Go for it.
I think you need to be a panelist to annotate, so I'm not sure how that would work now.
So you can write in the chat, which ones do you want me to remove, and I can mark them. That's why I like that my toothpicks have colors, because then you can say the green one on the right, or the green one on the left, or the green one on the bottom. And then Tiago can let me know, and I can mark them.
Well, meanwhile, Stacy Smith gives us a solution. The asymmetric solutions are to remove the 4 diagonals from the top to bottom on one side of the middle and 2 for the top of the opposite side, or tip of the opposite side. Sorry about that.
So like, wait, 2? I didn't understand the second part.
The 4 diagonals
So
from
all 4 of them?
top
Okay.
to bottom,
Okay.
and the middle, and 2 from the tip of the opposite side.
Stacy, am I marking the right ones?
No, not quite.
That's what I figured, because I'm like, I'm not seeing this.
So if you imagine them as being lined up in sort of 4 columns, all the diagonals, then if you take out one of the center columns, either the purple, green, purple, blue, or the red, blue, red, purple.
Oh, okay. So I'm going to take this one because that's the first one I mentioned. Okay.
And then on the opposite side, the green and yellow that make the tip.
Green and that makes more sense. Okay. Thank you, Steve.
And that can also be mirrored.
Okay, so let's see. And we have left 1, 2, 3, 4. Yeah, I can see it. Looks good to me. What do you think, Tiago?
That seems amazing.
The other difference is that it doesn't leave any squares.
Thank you, Stacy. Thank you very much. And of course, you mentioned that you can do the same thing, you know, symmetrically. Brilliant. Thank you, Stacy. So, Tiago, any other possible solutions, or are we ready to move on to the next one, which somebody already gave away?
I think we're good to go for the next. So Rafa had come up with the same solution, or this was one of the solutions that Rafa gave. So we have at least these 4 solutions.
Wonderful. So somebody already gave it away, but in fact, our next problem is to remove 4 toothpicks to leave only 4 triangles. So as I mentioned, some of you had already gotten that, that we were moving in that direction. And we've already seen that there's a variation, like Sergio mentioned. We could have asked to remove 6 toothpicks and leave only 2 triangles, and that's also possible. So if you can think of any other variations as well, you can let us know in the chat. Oh, Rafa, yes.
If you remove the 2 of the left, the red and the yellow.
Yes. Okay.
Yes, for example, the 3 of the bottom.
The
blue, the green, and the purple.
Okay, the 3 of the bottom. Okay. Oh, so you're going back to the 6. Okay.
And the rest of the top.
Oh, this red one. Okay.
Yes, you have 4.
Oh, I like this solution, Rafa. I really like this solution. That's very nice. Okay. Did you want to share another solution?
And the other solutions are symmetrical or are similar to the order that they said before.
Beautiful. How about with 4 toothpicks? Have you thought of that one? The one that we're looking at right now, remove now 4 toothpicks to leave only 4 triangles. So it's the same as the one before, but now instead of removing 6 toothpicks, we're removing only 4 toothpicks. That's okay.
But at the moment, I didn't think about that.
That's okay. So, Rafa, where are you from?
From Spain.
Wonderful. Hi, I'm from Panama.
Yeah.
Okay, so Tiago, do we have any other comments in the chat? Thank you, Rafa.
So we are starting to have a lot of comments, but I would just like to highlight the one by Sergio, which is Magnifico Rafa, because I also found this a very nice solution that I had not seen myself either. But now to the new puzzle with the 4 to make 4 triangles. Varun is giving us the solution that to remove the red, blue, green, and purple that make an X in the center.
So you see, like in the center, there's like a red, blue, green, and purple.
Yes. So you want me to eliminate those?
Yeah.
Okay. These 4.
Yeah, those 4. And then you have like 2 small triangles and then 2 big triangles.
Oh, so you're seeing them like one inside of the other one.
Yeah.
Wow, that's really cool. Okay, that's really cool. Okay, because I just looked at it, I'm like, wait, what? Okay, so you have the little one here, the purple, yellow, and green, the small one. And then you look at the bigger one over here that includes the small one. That's
And
wonderful.
then you have the same thing on the other side.
Beautiful, Varun. Loved it. Thank you. Are we accepting triangles inside of triangles? What do you think? Or should they be like completely separate triangles?
It didn't say that like they can't be inside each other. And there's no toothpick that's like not part of any triangle.
Perfect. Thank you, Varun. So Tiago, do we have any other comments in the chat? What are we thinking?
So Fernando was giving us the same solution as well. Alexandra is giving us remove 2 blue and 2 violet in the middle.
The 2 blue, so I'm guessing these 2 in the middle and the 2 violet. Ooh, yeah. Sorry, hold on, that one went a little too far. Well, that's okay. And that one. So let me see if I can fix this one because it almost went, there we go. Almost went all the way to the green. Okay, so the 2 blue ones in the middle and the 2 purple ones in the middle. And do we have 4 triangles left?
Well, this solution is actually similar to the previous one because you again have 2 big triangles and 2 small triangles, but now they are on the side of the big triangles.
So in the previous solution, the main triangle was, the little triangle was the one here in the tip. Now it's here on the side.
And now it's on the side.
Beautiful. Thank you, Alexandra.
And of course, you can choose half of this picture to do the triangle on the side, and on the other half to do the triangle on the top, and then you have more solutions.
Beautiful. Thank you. So we found even more solutions for this puzzle. Tiago, do we have more comments?
We have more. Arya Kumar says, remove the red, blue, purple triangle on the right and the bottom blue pick.
Red, blue, purple. Red, blue, purple on the right.
And the bottom blue one.
Bottom blue one. Okay. So I'm guessing the colors in the toothpicks are actually helping, huh? So let's see. What do we have?
Hello. Yeah, so I used the strategy we had before where you removed 6 to get 2 large triangles, but I only did that for one of the large triangles, and then I removed another one so that we had 3 other solutions. And now we have 4 triangles that do not overlap.
So you can see that we have 3 small triangles here. And what Ari is saying that we take this big triangle right here, and then we do not have any overlap. Love it. Okay, so should we see this 6 toothpicks that you want to remove? Which ones do you want to remove, Aria?
Okay, remove the top red one.
Okay.
The top blue one.
Okay.
The bottom red one.
Bottom red.
That purple one.
Purple. Okay.
Then you can remove the green and the blue ones on the bottom as well.
Green and blue on the bottom. Okay. So what do we have left? What do we have left, Aria?
We have the small triangle on the right, and we have the 3 connected triangles on the left.
Beautiful. Loved it. And I don't think we had seen this one when we were looking at the 6 toothpicks puzzle. So this is wonderful. Thank you, Aria. Now, which one did you find first? The one with the 4 toothpicks or the one with the 6 toothpicks? Just out of curiosity.
The one with 4 first.
And then from that one, you found this one?
It was a bit unrelated. I found the one for 4 while we were discussing the 6.
Oh, wonderful. Well, I always like hearing how you come up with these solutions because it's always, I don't know, I'm curious.
One more thing.
Oh, sure. Go ahead.
For the question of whether we should count overlapping triangles, I think we should, but we should also try and give a preference to solutions that don't involve overlapping triangles so that because I think we can consider those more elegant, but if they don't exist, then we can turn to overlapping triangles.
I agree with you, Arya. I think we should look at all possible solutions, but I also think that the ones that do not overlap are neater. But yeah, I agree. Thank you, Arya. So Tiago, more comments.
There are more people supporting the embedded triangle solutions. G gives us another solution, which is blue, green, and purple in the inner left, and the red on the right. Which gives one big triangle and 3 small ones, which I think we have seen something similar previously.
I think we have.
And I'm a little bit lost that there were a lot of answers. Varun gives us another one, is red on the top, blue one in the middle, purple one in the middle, and blue one on the bottom.
Ooh, that I don't think we've seen. Okay. So this one. Beautiful. I don't think we've seen this one before.
Okay, so this one actually, like, the triangles don't overlap.
Mm-hmm.
And they're all small triangles, but they do intersect in the corners.
Mm-hmm. But I think it's beautiful, and the symmetry is amazing.
It's not exactly symmetric, but I think it's not exactly symmetric because there's one on the top and one on the bottom. And then there's the left and the right one.
There is still symmetry, right?
I don't know, because like there's one on the left.
Tiago going like, yeah.
I think there's a one, yeah, Bob Hearn is correct. I think there's a 180-degree rotational.
Exactly, rotational symmetry is being pointed out. And I would argue that there's always the identity, but
Tiago. So Varun, thank you very much. I actually really like this solution. This is a very, very neat and beautiful solution.
And you could do it the other way, like if you did the purple, green, red, purple one.
Yes. So
like that would be the same thing, except it would be starting from the left.
Yes. So we could also, what Varun is saying, that we could also do this as well. And we would get 4 triangles. Again, only 4 triangles. Thank you, Varun. I really like the solution. Tiago, do we have any other comments?
So far, none further.
Okay, so how are we doing with time? Can I show one last puzzle and maybe have them do it as a homework or something?
I think we have time for one more, and if you want to speak a little bit longer about it, or if people have other questions about FUNDAPROMAT, or want to speak a little bit about it, I think we still have some time.
About life and such. Okay, so here we go. Let's look at this next puzzle, which is one of my favorite puzzles ever. So if you've seen this before, please do not say the answer. If you haven't seen it before, then enjoy. So in this puzzle, we see 9, 3, 4, 5, 6, 7, 8, 9. Yes, 9 toothpicks, which form 3 triangles. And we're asked to move 2 toothpicks to leave no triangles. Now, again, in the previous puzzles, we've asked to remove the toothpicks. So when you remove them, you just throw them away. Done. But here, the puzzle is asking us to move 2 toothpicks, which means that we're going to grab them from their position and move them somewhere else, but only 2 toothpicks. You cannot cut the toothpicks in half. You cannot use one toothpick to move another. And well, let's see what people think.
So people are already smelling a trick and suspecting that there is some sort of subterfuge to solve this puzzle.
So I have to admit, like I just said, this is one of my favorite toothpick puzzles ever.
So Glenn is already proposing a cheat to use one toothpick to move all others, but I think that was forbidden by the rules.
Yes, I just said that you cannot do that, even though it's not written in the slide. Yes, you cannot use one. Well, technically you don't have to write it in the slide because it says move 2 toothpicks. So if you use one toothpick to move another, then you're actually moving 2. And you can only move 2, no more than 2.
So Vivian is asking if we can use one toothpick to cross out another, and if that would still count as a triangle or not.
So that's a very good question. So what are you proposing, Vivian? Do you want to mention how you would like to, here, I can annotate whatever you say, and then we can look at it and decide amongst all of us what we think about it.
Maybe I'll take the yellow toothpick from the first triangle and
okay.
and put it in diagonal on the last triangle, just to strike it out. so that it doesn't look like it's still a triangle, but it's struck out. It's removed, so you don't count it anymore. Maybe it's cheating.
Yes, because, well, I don't know about you, but I can still see the triangle there. Like there's
no, I don't. I don't see it.
You don't see it. So yeah, I'm not sure that's gonna work, but that was an excellent first thought to start the puzzle. Thank you, Vivian.
So Bob has pointed out a very interesting solution. And CoM has also mentioned that he can move 1 to leave no triangle if we are allowed to move 2. So CoM has said he can move 1 to leave no triangles, and Bob Hearn is saying that we can remove red and blue and have triangle minus triangle, which is
beautiful, Bob. Yes. So we remove the red one and the blue one, and we put them right here. And then we get triangle minus triangle equals no triangle. So what are people thinking about this solution?
In general, people approve.
So the first time I saw this puzzle, I just thought it was amazing. It just blew my mind. And so I like to show this particular toothpick puzzle as a magic trick, which I know it's not really magic, but now that we're running virtual events, it's a little bit difficult, like Tiago knows, to run magic, any kind of performance on virtual events, right? And so I like to show this as a magic trick, because no matter how you try to move these toothpicks, when you try to move only 2, let's suppose that we just remove 1 toothpick from 2 of these triangles. No matter which one we remove, we're always going to be left with the 3rd triangle as a whole. So clearly there must be something going on here, because by moving only 2 toothpicks a regular way, or the usual way that we might think about it, it's probably not going to work. So yes, you have to come up with something magical or special, or even different, however you want to put it, in order to solve this puzzle. So that's how I like to show it. And usually people take a lot longer to try to figure this one out. So Tiago, what comments do we have in the chat?
So we have a very big mystery still up, which is a CoM solution with 1 single toothpick. To which there was no answer so far.
So I love this. I love the variation to this puzzle. So now CoM is saying, can we, well, is he asking, can we, or is he just asking us to do it? Is it possible, or is he asking us to do it? Because those are 2 very different questions.
Okay, so you may or may not like this one, but here it is. Take the red horizontal toothpick and rotate it clockwise 90 degrees.
Okay.
So that makes the first triangle, it turns it into an N, and then the middle one could represent an O, and then you have an honest triangle on to the right of it, so you get no triangle.
I love it, CoM. Love it.
Little silly.
What do others think in the chat, Tiago?
I think they're awestruck, and people say it's wonderful, nice, they love, and it's great.
Loved it. Thank you, CoM. That's awesome. Thank you. That was really, really cool.
And EDB Events points out that it says no triangles with an S.
That's a good point. So, CoM, do you want to say something about that?
So
EDB Events.
I don't have a problem with the S. I mean, in English, you would probably say, I mean, I have no triangles, no triangle. I think it's.
Do you still accept it, CoM? I think it works either way. What are we thinking?
Oh, I see that the picture then would be one triangle, yeah.
So,
yeah, it's a bit of a fiddle, I guess. If your question on the slide here said no triangle, it wouldn't have changed anything that happened before. Everybody would have come up with the same solutions, and then mine would be valid.
So I think we have two amazing solutions to this puzzle. First, the minus of the triangle minus triangle, leaving an empty. And the second one with the comic twist, I think are an amazing finish to our session. Unless you have more puzzles for us, Jeanette.
By moving only one toothpick. So I really like that. Yes, I do have lots more toothpick puzzles, but next time. Next time, Tiago.
So we already have a promise for next time. Hopefully we will see that soon. I think we have had an amazing puzzle session. Overall, we had a lot of solutions to very interesting puzzles. We got into talking a little bit about language ambiguity in mathematics and in puzzles, even talk about rigor and elegance in these. Not sure if you want to comment on anything more, but else we are running at an end. If anyone wants to ask anything as well, please do.
So I really love that there was a lot of participation. That was really awesome. So thank you everybody for participating and for sharing your thoughts about these fun puzzles and extensions to the puzzles as well. So do we have any questions, Tiago?
No further questions so far. People are thanking you very much.
Okay, that's wonderful.
I thank you too very much. It was a very, very interesting session.
Had you seen these puzzles before?
I have. Although I must say that most of them I did not recall.
You did not what?
Especially the solution to the last one. I think I puzzled about that one and then I went, oof, and I forgot about it. But yeah.
Yes, I think toothpick puzzles are a lot of fun and they also help you exercise your brain. So and they enhance your mood. You feel less stressed and you feel happier and whatnot. So yeah, these are a lot of fun.
A question just got in, which I think can also be a good suggestion, which is, do you have any puzzles where the colors are part of the solution?
Ooh, that's a very good question. So actually the colors, I just did them randomly. I didn't choose them in any particular way, but that's something that I could look into. But no, in these puzzles, the ones that I showed you today, there's no connection with the colors. They're just random. So I should probably mention that when I did this presentation before, all the toothpicks were the same color, and I just felt like, I don't know, that something was missing. So that's why this is the first time that I'm actually presenting these puzzles with colors. So
and it's been working lovely. It's been a very good way to indicate solutions.
Yes.
The big question is, do you have an encore? Do you have a small thing for us to take home with us to think about, or can you point us somewhere interesting?
Point you somewhere interesting? I'm not sure, but let's see. So I don't know which one's going to be the next one. So it might be an easy one or a difficult one. We'll see. I don't remember which one comes next after this one. So let's see what comes. Ooh, this is a good one. Okay, there. That's a good one to take home.
So we will not be discussing this last one, but you can see it here. You want to give us a quick explanation before we start ending our session?
Of course. So the image shows a distance of 100 meters. And here the puzzle is asking us to move 2 toothpicks to convert this distance into the smallest possible distance. That's it. That's what the toothpick is saying. So now what I can do is maybe show you again my contact information, just in case you have any questions, you want to discuss the solution to that puzzle, or you want to know more about toothpick puzzles or FUNDAPROMAT in general, feel free to contact me and I would be happy to talk to you in Spanish or English.
You know a lot of languages. So yeah, definitely check out FUNDAPROMAT. As I cannot stress enough, Jeanette has been organizing these amazing web seminars in Spanish, and they are still ongoing, I think, no?
Yes, we organize between 5 and 7 virtual events per week.
So definitely worth, I mean, I've been able to take part in multiple of them, and all of them were great quality, and I really enjoyed them. Just to leave the plug for you guys. And
actually, Tiago, it's really funny because some of the people who joined today were speakers for FUNDAPROMAT's virtual events. So you, of course, Fernando Blasco, Sergio Belmonte. So they were all our speakers in virtual events. So I'm very excited to see them again here.
So I think we shall end our session here. If you want to leave a last message.
Yes. Enjoy playing with mathematics.
One more time, thank you so much for this amazing and very fun session. Thank you, Jeanette.
Thank you, Tiago, and thank you to all the participants. Bye.